Hi, everyone. So today we're going to be working on quiz 3 review on section 11.4, additional problems. So what I'm going to be doing is I'm going to be sharing my screen and we're going to be working on the expected binomial formula. Okay, we're going to do some practice problems on that section. So this first question is asking you to find the probability that 6 rolls of a fair die will show 4 twos. Okay, so then how many options? So the number of rows then is equal to 6 rows. So 6 times you're doing your experiment and you're finding exactly 4 twos. So X is 4. The probability, what is our chances when we throw a die? So 1/6. So the probability is 6. And we rolled it 6 times and we should end up with exactly 4 twos. So then what we're going to do is we're going to use our formula. We have everything that we need. What we're only missing is Q. Remember, Q is the same as 1 minus P. So Q is 1 minus 1/6. Q is 6 over 6 minus 1 over 6, which is 5/6. So here we're going to just apply our formula, which is n factorial, 6 factorial over x, which is 4 factorial, 6 minus 4 factorial, p to the x, so p is 1/6 raised to the x, which is 4, and then we have 5/6 raised to the 6 minus 4, because it's 6 minus 4. Okay, and then here, well, this is just scratch work. You should know how to do this. This is 6 factorial over 4 factorial, 2 factorial, 1/6 to the 4th, and then 5/6 squared. Now here we have 6 factorial and 4 factorial. Well, this is 6 times 5 times 4 factorial over 4 factorial, 2 factorial. The 4 factorials here will cancel. You're going to be left with excuse me. So your 4 factorials will cancel. And you're going to be left with 30 divided by 2 factorial because 6 times 5 on the top, which is equal to 30 divided by 2 times 1, which is 15, times 1 over 6 to the 4th, and then 5 over 6 squared. So in this case, you just use your calculator. So I'm going to do that right now. I'm going to punch this on my calculator. You are allowed to use a calculator for your test. So you're going to go ahead and say, okay, well, what is 15 times 1 over 6 raised to the 4th? So let me do multiplication here. And then times 5 over 6. It's going to be a fraction, of course, raised to the square. And then you're going to end up with the decimal going to be 0.008037. So this is your answer. This is your solution. Okay. So that's the solution you'll get when doing that Bernoulli. Similarly, find the probability of a test has 40 questions, so your total n is 40. Each has 4 possible answers, so your probability is 1 out of 4. And find the probability of exactly 15 correct. So then now x is 15. So you need to find, this is going to be a large number. So of course you have q to be 1 minus p. So your probability is 1 minus 1/4, which is 3/4. So you're going to, again, use your formula, n factorial over x factorial, n minus x factorial, p to the x, and then p to the, q times 1, n minus x. So let's plug that in. We have 40 factorial over 15 factorial, 40 minus 15 factorial, P is 1/4 raised to the 15th power. And then of course, this is 3/4 raised to the 25, because that's 40 minus your 15, you get 25. So then you want to go ahead and punch this on your calculator. There's also Wolfram Alpha that this is a really good calculator if you're doing a computation that this is this large. So I'm going to go ahead and show you really quickly what that looks like on your end. So then you should know when to use Wolfram Alpha when you have large numbers. So let me go ahead and share my screen here. 1 second. Okay. So we have here our Wolfram Alpha. So we have, what we're going to do is we have 40 factorial, and then down here we have 15 factorial times, we have to be very specific, 40 minus, well, in this case, it'd be 25 factorial. And then making sure that that's correct, times, now this is 1/4 raised to the 15th power, and then this is 3/4 raised to the 25th power. And let's double check that this is correct. So we have 40 factorial divided, so you have to be careful here. See? Let's close that. So what we're looking for is 40 factorial divided by 15 factorial, 25 factorial. So that looks like this. Okay, so let's go ahead and close this loop. Oh, let's close this loop. Okay. So we have 40 factorial. Close that. 40 factorial divided by 15 factorial times 25 factorial. Let's close that. And then that times 1/4 raised to the 15th times 3/4 raised to the 25th power. Yes. So here 40, and then this actually has to go up. So we have the first part is correct. Times, so let's get rid of that. So we have this so far, right? And then we want this multiplied by, we have this value. And then we have to multiply that by 1/4, or let's do this, something better, 0.25 raised to the 15th power, and then times 0.75 raised to the 25th power. Close that, and let's see if that works. And it still brings it downstairs. But let's see here. Let's get rid of this. So we have this that works. So this is the result. So it's this times, oops, times exactly this. Yep, there it is. So what we want to do is make sure you're calculating this correctly using Wolfram Alpha or your calculator. And our answer should look like this. It should be 0.02819. So it's probably going to ask you to round to the nearest thousand. So this is the tens, hundreds, and thousands. So it's going to be 0.028. Okay. So make sure you're using the appropriate calculator. That's what I'm trying to say. The last example we'll do is number 3. This one's already kind of given to us, the 12, the probability is given, and X is given. The only thing that is not being given is actually Q, which is 1 minus P, which is 1 minus 0.6, which is 0.4. So again, it's just a matter of plugging and chugging here. This is the formula again of the Bernoulli. Well, here, let me write down the original first, P to the X and then Q to the N minus X. So let's try that. It'd be 12 factorial over 7 factorial, and then of course 12 minus 7 factorial, 0.6 raised to the 7th, and then 0.4 raised to the 12 minus 7. So we have 12 factorial over 7 factorial, 5 factorial, 0.6 raised to the 7th, and then 0.4 raised to the 5th power. Now we can simplify this because I want you to do that. 12 factorial, it's 12 times 11 times 10 times 9 times 8 times 7 factorial, all over 7 factorial, 5 factorial. The 7 factorials will cancel, but I'll still have 12 times 11 times 10 times 9 times 8. Okay, and then we have 5 factorial, and then we have 0.6 raised to the 7th and 0.4 raised to the 5th. Now, again, this is now a calculator problem. So let's do that again. So I'm going to be using Wolfram Alpha. So what I have is 12 times, well, I'm going to find what's 5 factorial. That should be easy. 5 factorial is 120. So 5 factorial, sorry about that. So 5 factorial is 12 times 11 times 10 times 9 times 8 divided by 120. Well, 120 is the same as 10 and 12. So you only have 11 times 9 times 8, all over here 1 times 0.6 raised to the 7th and 0.4 raised to the 5th. Now let's find what is 11 times 72, because that's what it is. That's 792. So 792 times 0.6 raised to the 7th, 0.4 raised to the 5th. Let's do that on our calculator. 972 times 0.6 raised to the 7th power, and then times, of course, 0.4 raised to the 5th power. So let's see if that does it calculated. Yep. And this gives us roughly, using my calculator, 0.27862. So rounding 0.279. Okay, because the 6 tells us to bump up. Okay, so this is the last part of 11.4. I did a lot of problems with that. So it's just practice and practice and practice, making sure you know how to use your calculator appropriately. Other than that, if you have any questions, email me. I am happy to assist you all the time. Okay, I will see you guys until the next recording. Bye.